Today we're going to be talking about the quadratic formula. And hopefully, quadratic formula is going to be something that you have seen in Algebra 1 and geometry as well. But let's start with solving this quadratic by graphing. And so what we can do is we can take this x squared minus 3x plus 4, and we can type it in the calculator. And I think I might have mine in the calculator already, and I do. X squared minus 3x plus 4. And when we type this into the calculator, we get this picture. And if we want to figure out the values on our graph, we can go to the table function. Remember that typically what happens is that I look for values that will fit on the graph. For instance, -1, 8, 4, 0, 4, 1, 2, 2, 2, 3, 4, and 4, 8. And it's nice that we can see the picture, but there we have that. And it says, based on the nature of the roots, do we think this quadratic is factorable? Well, maybe I should have asked a more obvious question first. What are the roots of this quadratic? Jordan? None, he says. And there actually are some roots, but we cannot tell what they are. Do you have any reason why you think we might not be able to tell what they are? Jordan? Because we don't cross the x-axis. Let's say when the graph does not cross the x-axis. The quadratic is not factorable. And I got wordy on that. I hope you can shorten that a little bit. When the graph does not cross the x-axis, the quadratic is not factorable. But what I said is there actually is an answer to this problem, and we'll talk about that in a couple minutes. But let's get a little bit of background here. There's many methods for solving quadratics, and the two that we've worked on so far are graphing and factoring. These two methods work best when we actually can see the answers. What we said on Monday is the answers were whole numbers, was one of the answers that I said. How can you tell if it's factorable? And that was one of the ways that we said we could do it. When we can't factor, or when graphing doesn't give us an exact answer, what we can also do is we can use the quadratic formula. And solving by graphing, solving by factoring, solving by the quadratic formula, these are all different methods to find the roots or the zeros or the x-intercepts of a quadratic equation. And what I have here is I have the quadratic equation listed. It is the opposite of b, plus or minus the square root of b squared minus 4ac, all divided by 2 times a. And again, I think that you're familiar with that. But there's one thing that I do need to remind you of, and that is that the quadratic equation must be set equal to 0 to be able to identify what a equals and what b equals and what c equals. It must be set equal to 0. But what I want to look at is, well, I wonder what are the answers to the problem that we graphed here just a couple minutes ago. Well, I know that it's not set equal to 0, but we have done this before. We could have rewritten this as 0 equals x squared minus 3x plus 4. And what we want to identify first is, what does a equal, what does b equal, what does c equal? Well, a equals 1. It is the number in front of the x squared term. B is negative 3. It's the number in front of the x. C is the constant. We do need to have it written, the quadratic equation written in this order. X squared, then the x term, then the constant. And if we do, then now we can put this back into our quadratic formula. And it is. It's x equals the opposite, or negative b, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So remember, 2 negatives together, the opposite of negative 3. 2 negatives together is a positive. If you have to type this in, negative 3 squared, make sure to put parentheses around it. Negative 3 times negative 3 is 9. 4 times 1 times 4 is 16. Divided by 2. 2 times a. Well, we're almost finished now. We need to simplify. 9 minus 16 is negative 7. And good practice for tomorrow. What happens when we have a negative underneath the square root? Tiffany? And she's close here. Square root of negative 1 equals I. So when we simplify this, we get 3 plus or minus I radical 7. We can't do anything with that 7. It's a prime number divided by 2. And those are the solutions to our picture. X squared minus 3x plus 4. Solving that when graphing. In other words, another conclusion that we can make, that I'm not going to write down right now, is because the graph did not cross the x-axis, we end up with imaginary solutions. I'm going to say it one more time. Because the graph did not cross the x-axis, when we solve the quadratic, we get imaginary solutions. That's not our primary focus today. Our primary focus is, let's use the quadratic formula. How can we use the quadratic formula? Practice using the quadratic formula. If you go, oh, I remember this, but I recommend that you still do a little bit of practice. And make sure that when we're solving by the quadratic formula, that our equation is set equal to 0. As we take a look on the first problem on the back of our paper, we see our equation is not set equal to 0. And by the way, you might want to start a little bit left on your paper if you can, just to have enough space. But when we look at this here, we can start by adding 3 to both sides. And the reason that we added 3 to both sides is so that we have our equation set equal to 0. Once we have our equation set equal to 0, then we can identify the fact that A is 3, B is 7, and C is 3. And now, once we identify those values, we can use those values back in the quadratic formula. X equals negative 7, also or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. Well, now, we get X equals negative 7 plus or minus 7 squared. Again, if you have to type it in, you have to type it in. 7 squared means 7 times 7, which is 49. 4 times 3 is 12, times 3 is 36. And 2 times 3 is 6. But we have one more step here. Well, what's 49 minus 36? And it is square root of 13 divided by 6. But we need to go back and look at what the directions say. And I should read the directions first, but at least I'm getting them in there at some point. The directions say this. It says solve the following quadratics by using the quadratic formula. We did that. Write the solutions in simplified radical form. We have done that. And that is called exact form. But it also says to put it in approximate form. We want to list out a decimal value for this. And what we do to come up with the decimal here is we can go back to our screen here. We can type it in. If you have a fraction button, use it. So Matthew parentheses for yours around the entire top part. And you know, you're good with your calculator here. If you have the fraction button, what we're going to type in is we're going to type in negative 7 plus the square root of 13 divided by 2. And let's round to the nearest hundredth, 2 decimal spaces. So we get negative 1.697, which is going to be negative 1.7. Did I type this in right? What did I do wrong? I forgot to put the 6. Darn it. Let's type it in correctly here. Second time a charm here. So how about negative 0.565? Much better when we type it in correctly. To get negative 0.57 as one of our approximate. Negative 0.57. But this is negative 7 plus the square root of 13 divided by 6. It is also negative 7 minus the square root of 13 over 6. And if you do have the newer version of the calculator, we can go back and highlight that value, press enter, and then when we type our backwards arrow here, all that we have to do is type in a minus, type in a minus, and that will give us our other value of negative 1.767. If we round to the nearest hundredth, that's going to be negative 1.77. And that is our approximate value. In other words, if we can write the equation in the proper form, I think that we can do rather well on this, especially with the quadratic formula provided for you, and at least for now it's going to be. So as we look at problem number 2, the difference from problem 2 compared to number 1 is that the equation's already set equal to 0. And we can identify what does A equal, and what does B equal, and what does C equal. So when we look at this here, A is 1. It's the number in front of the x squared term. B is -6, the number in front of the x term. C is the constant. And we're going to fill those values in to our quadratic formula. Watch out for this. It's negative b plus or minus the square root of b squared minus 4 times a times c, all divided by, that's what sometimes students miss, all divided by 2 times a. Well, if we simplify that, double negative, the opposite of -6 is 6. And if you have to type this in, remember you need parentheses around the -6 to give us positive 36, minus 4 times 1 times 1, which is 4, all divided by 2. So now we're close to finishing here. 36 minus 4 is 32. But the question now becomes, can we simplify the square root of 32? And good practice for our next quiz. Doesn't matter which values you pick. 4 times 8, 16 times 2. What we're looking for is we're looking for 2 of the same value to take out 1. And 4 is 2 times 2. And 8 is 4 times 2. And 4 is 2 times 2. So what we have for the 32, we have 1, 2, 3, 4, 5. And what we need are 2 of the same to take out 1. 2 of the same value. We can take out 1. We've got another 2 2's. We can take out 1. 2 of the same to take out 1. So we're left with 2 times 2. We have a single. That's still going to be underneath the radical. So we're going to take this value now. We just simplified the square root of 32. And we're going to get 6 plus or minus 2 times 2 is 4 radical 2 over 2. And the last part here is we can take this one step farther because 6 and 4 and 2 all have something in common. In fact, 6 and 4 and 2 in this case are all even numbers. We can finish this problem by dividing 6 by 2 to get 3. Divide 4 by 2 to get 2. Divide 2 by 2 to get 1. And in reality, we don't need to necessarily write the 1. If you write the 1, I'm fine with that. That's not going to make any difference. But it's 3 plus or minus 2 radical 2 is the values for x. Those are our exact. But we also want to know what are the approximate values. So our approximate values, we're going to go into the calculator And I'll try to type it in correctly this time. 3 plus 2 times the square root of 2. And we get 5.83. So we get 5.83. And again, depending on your calculator, you can highlight it, or we just have to type it in again. 3 minus 2 radical 2 gives us 0.171. Rounding to the nearest hundredth gives us 0.17 for our approximate. In other words, what you're seeing is there are 2 solutions for these problems. We kind of have a routine now. We look at our equation, we make sure that the equation is set equal to 0. In this case, it is not. We identify A, B, and C, and then we put those values back into the quadratic formula. There's one piece of advice that I have for you, and you don't have to follow it, but the problem tends to be a slight bit easier if you keep your x squared term positive. The problem tends to be a slight bit easier if you keep your x squared term positive. So what that means on this particular problem here is that I would move 10x over to the other side, as well as 20. It won't change your outcome. It's just a recommendation. But regardless, once we get the equation set equal to 0, we want to identify what does A equal, what does B equal, what does C equal. So A equals 1. And B equals negative 10. And C equals 20. If you have A equals negative 1, B equals positive 10, C equals negative 20, you are fine. We're going to fill this into the quadratic formula. The opposite of B, plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. And once again, 2 negatives make a positive. The opposite of negative 10. Negative 10 is positive 10. If you do have to type in negative 10 squared in your calculator, make sure to have parentheses. Negative 10 squared is 100. 4 times 1 times 20 is 80. Divided by 2. Simplifying a little bit more, we get 10 plus or minus the square root of 20 divided by 2. Can we simplify the square root of 20? We can. 4 times 5, 10 times 2, it does not make a difference of what you use. But when we look at this, remember, we need 2 of the same value to take out 1. We have 2 2's. So this becomes 10 plus or minus 2 radical 5 divided by 2. Those are the values that x equals. The question becomes, can we simplify that more? Any nods of your head? Nothing? And not only are we going to divide the 2 into 10, it's 10 is going to be divisible by 2, the 2 is divisible by 2, and this 2 is divisible by 2. We can, again, it turns out that these are all even numbers, and even numbers are divisible by 2. 10 divided by 2 is 5. 2 divided by 2 is 1. You don't have to write that 1. 2 divided by 2 is 1. If we write it in a little bit simpler manner, we get 5 plus or minus square root of 5, which is our exact answer. I'm not going to spend the time to type it in the calculator, but I will tell you that 7.24 and 2.76 are the approximate values. I do want to do one more. I know I'm not quite going to finish the notes, but I do want to do one more problem to finish today. And the nice part is that on problem number 4, the equation is already set equal to 0. So we can identify that A is 2, and B is negative 2, and C is 5. And we're going to fill in the quadratic formula. Our x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Well, we simplify a little bit more here. Negative and a negative. Double negative gives us a positive. If you're typing this in, you need parentheses. Negative 2 squared is 4. 4 times 2 is 8, times 5 is 40. Divided by 4. Well, we keep simplifying. And what we end up with is 2 plus or minus the square root of negative 36, 4 minus 40, divided by 4. And again, what happens when we have a negative underneath the radical? What kind of number do we have? Oscar? Square root of negative 1, which equals, Tiffany, an imaginary number. Both of you, right on the money. Square root of negative 1 times square root of 36. Can we take the square root of negative 1? Well, we have a value for it. The square root of negative 1 is I. Can we take the square root of 36? And it is 6. So this is 2 plus or minus 6i divided by 4. As we finish this problem, we need to note that 2 and 6 and 4 are all even numbers. So we can simplify those. 2 divided by 2 is 1. 6 divided by 2 is 3. 4 divided by 2 is 2. This is the exact answer, by the way, and in fact it means 1 plus 3i divided by 2 and 1 minus 3i divided by 2. Can we get an approximate solution? No.